Hi everyone. Let me give you a quick introduction into a detailed explanation of this agent we built with the MuleSoft AI Chain project by combining the Inference connector with the new officially released MCP connector, which allows you to implement tools for your agents. Um, so this is a simple agent we built, which is intelligent enough to reason upon any request which comes in and identify if it should be using its general knowledge or if it should be using MCP to execute tools and data from any system which is available through the MCP server. So what we can start with a simple query. What is the capital of Switzerland? That should be easy. And the way the agent is answering is, of course, with the answer, but it provides additional insights to it as well. So burn, okay, that's correct. Reason and action plan is step one is general knowledge. So LLM says I can answer it with my knowledge, no need to call out any tools. So no tools are used, but it provides some insights as well. So these are some parameters which I'm setting. I will explain this later when we discuss the mule flow. But for now, you can see the plan was to get the capital of Switzerland and no tools are used. So far, so good. I can also ask this agent, what tools do you have available for you? Let's see what it answers with. It says I have 4 tools available, and these tools are submit delivery, submit order, get accounts, and get inventory. Okay, cool. That's nice. And it even invested a thought for me to list me all the available tools. General knowledge, no tools used, because these are the tools to use. Okay, let's say I would like to know check inventory for mule test 0. That's a simple call, right? So it has the tool available with get inventory. And it says I went into your system. This is the inventory detail, quantity available. This was my plan. And I have a thought which I want to share with you. I used a tool called get inventory. This is the call ID and so on. So that's pretty cool. So I am able to get data from SAP and it says I used a tool for answering your request. That's nice. So let me copy it and we rename it to, let's say 400-110. It's a different product. And we get, this is the unit available. Okay, and again, the same procedure with calling out tools and so on. Okay, now I want to combine it a little more complex and try to get more out of the agent. What could be the more? I can ask maybe for checking inventory for mule test 0 and put a condition. If available quantity is more than 10,000 units, only then create a single, create a sales order. Yeah, that should be fine. Let's go. So check inventory for mule test, and if available quantity is more than something, create a sales order. Now you can see it went into the whole thing, checking the inventory, creating the sales order, and returning 2 thoughts. Right, so this is one thought, getting the inventory, and the second thought is entering the sales order, which is super nice. So it was able to chain to request and it used the tool. So that's pretty amazing. That's a sales order which was created in SAP. And if I would like to do the same basically for the other one, let's say 400-110, and I expect it to not create any order because the unit is this and it's less than 10,000 units. So sales order is not created. It executed one request and the second request was just to reassure it meets all the requirement. And that's a simple way to get things done quite easily. And now I can go even further and try to combine more requests. So let's make, once the sales order is created, another condition, use the order number to create a delivery, or to process delivery, Let's go. And the delivery side, the delivery tool, which we also saw available, is just a mock. So it won't do anything in SAP. I'm just getting real-time data from SAP and using the create order to create an order in SAP in real time, but no delivery is created. It's just a mock here. But I want to demonstrate that it is able to chain tools together. So what did it do? It found the inventory details. It said this is basically the units, which is the threshold, and it goes beyond that, so that's fine. So I created a sales order. After I did this, I went into the delivery and created a delivery for this sales order. So it started to provide me three thoughts. The first is check inventory. Cool, that's fine. The second one is to go into the order system and submit an order, because now the inventory is higher than 10,000 units, and execute it. So that's basically what it did in the second thought. And the third thought is use the sales order number, yeah, which is created in SAP, and chain it together with a final request of submitting a delivery. And that's super powerful, because now you are combining things and building agents. And this template, which is behind the scenes, you can use for various use cases. You can add additional tools and try to come up with your customer use case to demonstrate this. And now let's take a look how it looks like in the MuleSoft Anypoint Studio. So this is Studio, where we have a main flow. And this main flow is just starting here with setting few variables. So I get my request in, whatever you enter in this user field, and enter. So it comes in here, and first of all, it sets few variables. These few variables are the prompt I will save, and then I enter few of those variables just as empty variables, and finally get the tools listed and save it into a variable, so I don't need to call it again. So that's number one. The second thing which is happening here is it is creating a plan. What is the plan about? The plan is about to ensure that the user's prompt, user's query is met. So what do we have? We have two executions in the scatter gather. And the first one is just defining what is the prompt template. Yeah, what is the plan look like? Because this first one is the brain and the whole controlling area for this agent. So it says you are a planner agent. Don't answer questions based on your knowledge, but don't make up things. Okay. I'm providing here a data set with the current user query. Yeah, what is the capital or whatsoever. Current observations. In the first entry, this is empty, right? So there is no current observation, and already executed tools is also nothing, because this is empty in the first execution. So the job, the instruction is you have to name tools, um, identify tools based on user's query, execute each tool only once. Don't suggest tools which are already executed in the executed section of the data here, this one. If more than one tool need to be executed, you need to respond with the following JSON: plan, your plan, multi-tools, true, and final false, because multiple tool execution. So if I put a condition on it, it will say I need to reiterate again, like check inventory for something, and if available quantity is higher than something, then please create a sales order. That's a condition. So it will first get the check inventory call. It says multi-tool is true, but then it will come back, because it's not final thought. It will come back in this plan and re-execute based on what has been executed. If one tool need to be executed only, then please set the JSON like this: multi-tool is false and final is true. And then after that no task is opened, set the final to true. That's also good. And I'm giving an example. If user asks check inventory for a product, this is how you should be creating the response and reasoning for. So that's everything basically. And the second one is the tool identification, the tool reasoning using the native capability of an LLM. Use MCP tools. So we are providing basically all the same templates here, except for one difference, which is the tools we got from MCP, we are entering here. And this one is not having any planner capability. It's just the reasoning over the tools based on the data and the same instruction the planner has, but it is identifying what should be the tools, what should be the chaining to be executed. And that's basically what is done here. And then after that, I save all the tools, all the information for the brain, chain of thoughts, and then I go into the assess and execute. The assess and execute flow is also quite simple, nothing special here. So we are saving the results of the planner, which is here, here, planning payload. We are saving into a variable called planning payload. And if I say, if this tool reasoning has provided more than one tool, then go into the tool execution. It will set the variable is here, the tools used plus whatever the planner is suggesting. And then I'm going into the replan execution. So I have the tool suggestion and I say execute single iteration. Yeah? So first, let's take a look here on the for each. Here you see I have the total tool suggestion of this one. So if it's one tool, it's one iteration. If it's two tools, it's two iteration because the batch size of this for each is two. Have one execution per per item. And if we have two items, then it will go for two iterations. So once this is done, we go and enter this replan tool exec. And this is nothing more than a tool call to the MCP server. So this is the client component. I have fully parameterized it. So you can see the tool name will be identified based on this reasoning. Whatever it got from the total tools and whatever it is suggesting, we come up and name the tool name and provide the right arguments to the MCP server call. And the MCP server call use this tool name and the arguments to call out the tools. I have four tools available. First is get inventory. This is here. The tool listener is really called get inventory. And if we recapture back, here you can see I asked what are the tools available to you. So you see here's get inventory is one tool. The second tool was get accounts. So that's here, get accounts. The third one was submit order. You can see submit order is here. And submit delivery was the fourth one. And here we have the submit delivery. So these tools are available, but based on different schemas, parameter schemas, and get inventory is here for material number, whatever the user is entering, plus a description. So the LLM, the agent which is built with the inference connector can reason upon it, and that's here, right? So that's the reasoning we have where we are adding all those tools and then allow it to execute using the call tools. And once I'm having the call tools, I'm taking that and converting it into a JSON and format it accordingly so I can use whatever is inside and go out here. I save all the results. If it's one tool execution, it's saved in the multi-tool result variable. If it's three tools execution, it's also saved in the same variables, yeah? But everything is saved. And once I have completed this, I go to the next choice and revalidate what the brain has suggested. The brain, if it has set the multi-tools to true, this is a brain, right? And this brain is setting the multi-tools. If more than one tool is needed, you have to respond with this JSON where multi-tool is set to true. If this is set to true here, then we are going into re-reasoning, right? And the re-reasoning is happening here. I'm recalling this flow. It comes back here with all the data which has been executed, all the results of the call, and reassess everything. This one is also reassessing. Now I have the inventory number, so I need to validate if it's higher than 10,000 unit, and if it is, I need to create the sales order. That's actually happening here. It is suggesting the tools, and this is creating the plan for the brain to re-reason or end the process. And that's happening so often when I also at the delivery, it will go into re-reasoning, go back here and complete the user request, where it finally exits everything with this template where all the data is presented, all the multi-tool result plus the user's prompt to answer the question, and just simple guidance that use this data to answer formally the question of the user. And that's everything what we have built here with um, with this agent. Yeah? So you can combine even all four tools together in a chain. Whatever would make sense, you can do it from here. I can try to tell you how it would look like. So let's go. We after process delivery, after process delivery, create a process delivery and get CRM accounts for, yeah, that should be it. Get CRM accounts. Let's see what it does. So that's the final big statement where it will go through all those reasoning and come up with a result which can satisfy the user's query. It will re-evaluate, it will re-reason until the plan is completed and all the data has been provided for the user. If there is a call error, let's say delivery API is not available, it will tell this also to the user that things were not going as expected, so I didn't finish with everything. It could be that it takes a little longer because the CRM account is too long and yeah, there's a timeout set. So it goes into the timeout. Nevertheless, you see how it is working, how you could combine all this together to make a very compelling demo to your customer and build the use case you would like to do by changing the tools and providing it um, for your customer context to build that demo. All right, so that's it, what we were using in this demo. This project will be shared also with you so you can start using it.